Okay, so we're going to talk about a free response problem over gravitation. So let's go ahead and read this problem. It says, a student is given a set of orbital data for some of the moons of Saturn shown below and is asked to use the data to determine the mass of Saturn. Assume the orbits of these moons are circular. So, this problem being about gravitation, there are two main laws that we need to remember. The first is Kepler's law. Now this says the period squared over the radius cubed is equal to a certain constant. And Kepler discovered this by taking data of different moons and different planets surrounding one particular body, one particular mass. So in his calculations, he was studying the planets circling the sun, and he discovered that no matter the planet, all of them, when put into this ratio, this equation, gave the same constant because the sun was the same. In saying that, that means that every particular object of mass, every star, has a particular constant in which when objects orbit it, it equals that constant. So that's what he discovered. The other law we need to know is Newton's law of gravitation, which says that the force of gravitation between two objects is equal to a constant times the two objects divided by their radius squared. So knowing that, let's see what they've given us. So they did go ahead and give us a set of data of periods and radius for different moons. And so the first question says, write an algebraic expression for the gravitational force between Saturn and one of its moons. Now this question is much simpler than you would think. You can leave the masses of Saturn and the mass of the moon in variables. So all you have to do is put these as mass of Saturn, mass of the moon, and so this is your answer, this is your equation. The next question asks, use your expression from part A and the assumption of circular orbits to derive an equation for the orbital period of a moon as a function of its orbital radius. So, the hint about circular orbits means that we're dealing with centripetal force since we're not dealing with ellipses. So, we knew the force of gravitation, and if it is the only force acting on the moon and in Saturn, then we know it's also the centripetal force. So we can say mv squared, which is the centripetal force equation, equals the gravitation equation. Now we don't have, it asks for period t as a function of r. We don't have t in this equation, so we got to relate v, velocity, to the period. So if you remember a circle, the period is the time it takes for the object to traverse the whole circumference. So circumference equals 2 pi r. So the time it takes, the distance traveled over the time it takes to travel that distance equals velocity. So velocity is 2 pi r over the period. Now we take that value, go ahead and fill it in for v squared, which I did here, and you can begin solving for t, which is the period t as a function of r. So this mass right here, this mass, is the mass of the moon. And so the mass of the moon is both sides. You can cancel it out. You start doing some math, square all this, cancel some more stuff out, and eventually you get to here. The period squared equals this whole value, r cubed. So they want you to go ahead and put t as a single value. So square root this whole thing, and then you get this. R cubed square rooted is the same thing as r to the 3/2. So that's why I put it like that. Okay, so that's your answer to part B. Now it asks, which quantities should be graphed to yield a straight line whose slope could be used to determine Saturn's mass? So this question is asking, how can you possibly graph this to make it linear so you can determine a slope? Because this equation is not linear, it's curved. So you can just go ahead and square the period and square all of this, and it'll give you, you'll be graphing period squared and r cubed, and that will linearize the the equation. So then you will be able to find the slope. So next two actually. Complete the data table by calculating the two quantities to be graphed. Label the top of each column, including units. Plot the graph on the axis below. Label the axes with variables and appropriate numbers to indicate the scale. So this is gone ahead and done. So here are the values, and then here is the graph made with the proper variables on the sides. So I went ahead and did this also on my calculator so that I could put the data into stat, regular R, regular T, regular R, T squared, and then R cubed. Go ahead and graph that, and you get the same line. It's straight. And then in part F, it asks, using the graph, calculate a value for the mass of Saturn. So in order to do this, we must remember that this is the equation we're graphing, which is linear, and I got this from over here. So this is the same equation. And if you look at it, it's just y equals mx. So this is just the slope, and there's a variable here. So this slope is the same thing as c, because right here, t squared over r cubed equals c, so it's the same thing as t squared equals c r cubed. So this is just slope. So I calculated the slope using my calculator, doing stat calc linear reg, and you get this value, 1.05 E15 as your slope. So you set this equal to this in order to solve for the mass of Saturn, which I did here, and your mass of Saturn comes out to be this value. So that's the conclusion of the problem. I hope that was a helpful video, and it helped you to remember how to do gravitation.